Me too. All right, welcome everybody to the first panel session of the day. I know that the title of the panel is a little bit of a mouthful, but we wanted to pull together a panel that focused on ODAS and small cells, specifically in the suburban environment, such as we see in the area around the city here. My name is Doug Fishman, for those of you who don't know me, and I'm going to be your moderator for today. Again, I'm an industry veteran. I've been around 25 plus years. I've done work for vendors, for a carrier. Right now I'm working for SQUAN, DAS system integrator, and in construction as well. And SQUAN has been generous enough to sponsor this panel. Joining me for the next 55 minutes or so, from left to right, are Dominic Villecco. Dominic is a 36-year veteran of the wireless industry. He's president and founder of VCOMM, an industry-leading telecommunications engineering consulting firm doing business nationwide for the past 21 years. Dominic's also vice president of the Board of Trustees and the chair of the Public Safety Committee for New Jersey Wireless Association, and received Drexel University's Distinguished Alumni Award in 2001. Let me get to where I'm supposed to be. Next to Dominic is Josh Broder. Josh is CEO of TILSON, a 230-employee network deployment firm with offices around the country. Josh is a utility pole site development and right-of-way expert, and his firm is currently managing the deployment of thousands of small cells, utility networks, and DAS systems in the right-of-way. Josh is a recovering network engineer who cut his teeth in field design building of the U.S. network in Afghanistan. And finally, at the end is Leslie Snyder, who's the managing partner at Snyder & Snyder. She's head of the real estate and communication practices and has developed a unique specialty practice involving real estate and telecommunications. Leslie has extensive experience negotiating and obtaining government approvals for switching facilities, distributed antenna systems, small site facilities, and rooftop installations. And for the past 3 years, she has been named to the New York Metro Super Lawyers list for her vast real estate and communications experience. In 2016, Snyder & Snyder was recognized in the New York Law Journal list of largest minority and women-owned firms in New York State. Okay, so the agenda for today, after my scintillating introductions here, we're going to divide up the discussion into 3 pieces. First piece will focus on RF engineering and design, and that's going to be Dominic. We're going to transition into pole selection, considerations with Josh, and finally with permitting with Leslie. And on that note, let me hand off the microphone to Dominic. You want to just sit there?
Thank you, Doug. Let's see if I can work this. There we go. Well, thank you for that introduction, and thank you everyone for getting up this morning. I know that, and getting here, Leslie and I were just running in last minute on time. I know it was difficult to get in, so I appreciate the audience. As Doug said, I'm going to talk a little bit about the RF engineering and design attributes and challenges that we've come across in ODAS designs and small cell nodes as well. I think the key here in whether it's ODAS or small cell is you're designing for low antenna heights above ground. And here we've got a picture of one. This is a node that's in Philadelphia. You could see here on this node, what you can see is the antennas are at the top of the pole, but there's a building that blocks it. So the issue that you have with this is limited height, limited coverage. That produces challenges, and because what we've seen, at least so far, most of these ODAS and small cell networks are being built to offload capacity of the macro networks. So these are typically very venue specific, they're typically very location specific, and as a result, what happens is it's very important to make sure that you cover the areas that you're trying to cover. So in this particular case, what you can see is you can see a picture here of the node, and you can see there's City Hall in the background, there's a building next to it. If we're trying to get down to City Hall, this location of this particular node has difficulty going up and down that street, but it doesn't have any problems going on the cross street. So it's important to when you're designing for these things, to really understand what the goals are. Clutters in the near field, that's exactly what you see here with the building. Clutter is in a near field. In this particular case, it's a few feet away. This is stone, this clutter, so this is a problem. Oftentimes we have trees and we have other things in the way. And the key here is really needing to work closely with real estate so we can design a network that's buildable. And then Leslie get into whether or not it's permittable, but the first thing is it's buildable. So the first thing is to really understand that we've got these low antenna height structures. We've got specific areas or venues or locations that we're trying to provide coverage or offload. And then on top of that, we've got to match that with real estate to figure out if we can actually come up with a location that'll do that. We've actually worked closely with TILSON on a lot of these, and the only way that it works is this collaborative back and forth until we find locations that do what we need to do. Effective foliage, this is part of the clutter, and oftentimes, most often, the nodes are actually below the clutter. And you get near field clutter effect. So in this particular case, what you can see is, I don't know how well you can see the picture here, but this is actually a crane test that we are performing. On the left side of the road, there are poles that are kind of buried in the trees. They're difficult to see. These poles, there was difficulty with these poles because they have primary power at the top, so there was an issue with trying to get antennas located on these poles. So we had to go to the other side of the street. So now if you look, what we're doing is we're testing a location that's going to have a new pole that's actually buried in the clutter. And what we're trying to do in this particular case is, this isn't like the last picture that you saw where we're trying to cover city blocks. Here we're just trying to connect some roads up and down, these what appear to be country roads in the picture. And the issue is we've got clutter. Now these are evergreen, so what happens is that clutter is there all the time. And in other cases, there's no leaves on the trees, and so we've got to allow for that, different seasons as well. And the biggest problem that we found, it's particularly harsh on the high band channels, 1900, PCS, AWS, WCS, and a 2500 band. The clutter just soaks it up, especially the trees. In this case here, like these evergreens, you've heard this for years. The needles are a function of the wavelength, and the bottom line is they're perfect absorbers or perfect attenuators, and you just don't go that far. So I'm trying to cover an area here on this road. I'm trying to connect these things. It's important to connect these. I'll show you that in a minute. It's important to connect them because we need continuity along the service area. CW testing is, the question is it a necessity and what's the purpose? And so far what we've seen, none of the propagation models can effectively predict the effects of clutter. That's one thing. The second thing is I don't know that anyone's got a database with those trees that I just saw you with all the clutter, so I don't know that we ever would be able to anyway. Again, the real issue here is we've got, and if you look at what we say here about the CW testing, one, it confirms the node location. Overlap with adjacent nodes is very, very important. Again, I'll get to that in a second. And then understand the future signal-noise ratio operating environment is extremely important for these nodes to work effectively. And this is the same whether it's DAS or it's small cell, it's the same issues. The difference with DAS and small cell would be, generally speaking, it's power. There's configuration differences as well, but from a coverage perspective, with the differences in power, other than that, they're more or less the same thing from a coverage perspective. Small cells are often a single carrier device. Sometimes they're a single band device. We've seen some multi-band devices coming out. The big thing with small cells is, at least so far, with most of the ones that we've seen that are being deployed, there's more power available because it's not shared among carriers. So more power means more coverage. DAS can be a multi-carrier network, But the downside of multi-carriers, we've got power sharing. So with power sharing, it reduces the footprint. So the more carriers I put on this node, the more times I have to divide it up, the smaller the footprint. However, DAS can be a very useful tool in areas with limited poles and with street furniture. And I know Josh is going to talk a little bit about that as well. And in this picture here, what you can see is here are two, I think this is a picture I knew of an area. It's not one that we worked on, but it's an area that I knew of. And I took the picture and we've circled two DAS poles. I believe this is a DAS, they're not small cell. Two poles next to each other. So these are two single carrier DAS systems. And if you look at there, you see what appears to be Asbury Avenue, and I don't remember what the cross street is there. But right down the block, the next adjacent pole is the one that's got the second DAS node on it. So now the problem I have is that I'm in an area like this, and now this is two carriers, but now I got the four carriers that are in the market today trying to serve the same area. I'm going to go up another pole in this direction, maybe down another pole in that direction, possibly over to the other side. One of the problems that you see here is the poles on the other side of the street have primary power at the top. That's a problem to locate antennas up near that. So it becomes a limited ability to try to serve the same area. And most of the carriers are trying to serve the same people, the same congregation points, the same traffic offload. And that's where DAS, when you're in an area like that, can really make a difference because I can combine everyone. Antenna selection is another consideration in doing this. So you've seen some of these pictures that I've shown so far that have sector antennas. You'll see this picture to the left, and I have to tell you, it's your picture, Josh. I stole your picture, but
that's okay.
I have to give Tilson the credit for that picture.
It's in good hands.
That's the Tilson vehicle there at the bottom of the picture.
Oh, yeah, that's on our Ford Escape, okay.
But it was a good picture. What it shows is the cylindrical antenna, or cantenna as many of you refer to them. It shows that at the top. So here we've got a communications pole. What we've got is we've got the DAS node down lower, we've got the cantenna at the top, and it's up relatively high relative to the clutter from what you could see here, and it's got pretty good line of sight up and down the street. So it's got pretty good, just looking at the picture, it would have pretty decent coverage. If you look to the right, what we have is this is in a city environment here. What we've got is we've got three sector antennas, and again, what we're trying to do here is we've got especially in a city environment, I'm trying to get down these canyons to a certain extent. I'm trying to get down these canyons, provide coverage in a certain area. I might need a higher gain. I might need a higher gain for the talkback path because the uplink, because I've got building penetration. I'm trying to get subscriber devices out of the building as well, not just penetrate in. So the antenna selections are very, very specific to the node, to the capability of the structure, whether it's a existing utility pole, new pole, whatever, or street furniture. And the primary difference between the sector antennas and the cylindrical cantennas are that the sector antennas, I can turn the beams a little more. There's variations in the beams on what you can do with the canister antennas, but I have just greater variability with the sector antennas and higher gain. So higher gain usually means more coverage. However, with the sector antennas, it uses up more space on the pole. Now, these are two RF plans that we have prepared, and what you could see here is, and this is what's significant, you can see here, what we've tried to do is we've tried to, and I'm going by memory here, the yellow I think is minus 85 and the red's minus 95. What's significant is minus 85 is what we're trying to cover. This is RSRP. This is what we're trying to provide in the area. The thing you have to remember is there's macro sites all around here. So in a situation where the cell carrier has macro sites that are already covering the area and we're trying to do offload, we've worked with them. In some cases, what they'll do is they'll shut down, let's say this was a high band system, they would shut down high band in those sectors that point in this area. Because the problem that we'll have is you could see, the one to the right, what you could see is for the most part we have contiguous coverage. There's a little red spot in the middle of the yellow. You've got to be very, very careful if there's a macro site that comes in there and we start to drop below this 85 and the macro site starts to come in with comparable signals or close, my signal to noise ratio rises, and all of a sudden I think I have great coverage, and I do. I've got 5 bars, but I can't get any throughput because my signal to noise is too high. So it's very, very important to make sure that the placement's correct, that we have this overlap, and you have to take into account these macro sites, whether the sectors are shut down, whether you're just doing certain bands in the sectors and in other bands in the small cell system here. You can see the one on the left, what we have is we have some more areas that are, I'll say choppy on the edge, if you will. But we knew that we have enough decent macro coverage there, and our focus was sort of this main drag, which is where most of the traffic was in this area. So very important, all these other considerations that we've talked about ultimately culminate into what you see here, and the real issue here, this is like reading an MRI. I'm reading this, and the question is, what do I really read into it, and what's it mean from a performance standpoint? The performance is the key. Like I said, you can put nodes up anywhere. Having 5 bars but no throughput doesn't help anyone. In fact, it just makes the problem worse. With that, I'm going to turn it over to my colleague, Mr.
Great.
Broder.
Thanks, Dom. That's a great introduction of kind of some of the planning considerations that go into siting these nodes. I'm going to talk a little bit more about what's going on in the streetscape, and I've got a few pictures here of nodes out in the field, and what I've tried to do, we talk a lot at these events about what's happening here in Manhattan and what the urban core looks like on the street furniture, and I've tried to take this out into the suburbs a little bit, and at the end of my slides I'll just show you some pictures of what these things are looking like when they're not in a higher end piece of street furniture. But as I get into that, I'd like to go back just to the drivers that we take with us when we go to the field and do site selection. And the drivers are that we have an increasing data usage in an environment where we have pretty good coverage. And so when we think of these nodes, not in every case, but in many situations, there's plenty of coverage but limited capacity. And so we're trying to densify these networks, and as Dominic so very well put, having 5 bars and no capacity is a real problem we need to solve for people who want to make use of mobile broadband. And so as we think about siting these facilities, we're bringing them much closer to where the users are and trying to make the best use of this very limited spectrum as we can at much lower powers and much shorter distance. We're trying to reuse the entire spectrum and in very short distances. And of course, as we do this, we're building a roadmap for 5G as we bring front haul fiber into all the nooks and crannies. And so not only are we thinking about this as an LTE densification project, but also to set the conditions for the front haul fiber we need to be successful. And so from a term standpoint, we talk about small cells, metro cells, DAS, CRAN. From a siting standpoint, most of our considerations are similar regardless of the technology or the size node. These nodes are getting smaller generally, which is great from being able to sort of tuck them away and be sensitive to the communities that are hosting these. But generally, we're putting them in the right of way. And there's been a lot of discussion about the irresponsible or the responsible use of the right of way. And I'll put in a plug here for being part of the solution in the right of way to collaborate with communities to get approvals. And Leslie will tell us about that approval environment. But I just want to plug in here that in addition to doing what's legally necessary, that it's really important to partner with the communities where we're going to put these nodes and make sure that we're being good stewards of the right of way and that these things look appropriate or appropriately sized and scaled for the places that we're putting them in, which also has the added benefit of typically meeting our RF objectives. We want them close to where the users are, and I don't think it's incompatible to meet that use case and also have sensitively sited nodes. There's also been a lot of discussion about turnkey and self-performance. Turnkey meaning that some provider other than the end cellular carrier is providing the facility, and self-performance being the carriers deploying them for their own purposes. For this discussion, I'm just really focused on the work as opposed to who owns the facility. And so I'll start with this image, and this is the site acquisition specialist of 2017. This is a field surveyor, and the reason I start with this picture is that the main difference as we move into the right-of-way as we consider site selection is that rather than fighting a battle of lease terms and conditions, we're fighting a battle of inches, and those are inches on utility poles and street frontage to be compliant with the various codes and design standards necessary to coexist in a very cluttered streetscape. And so when we think about what's the difference between the traditional tower environment that we look to sites in, and the right-of-way is primarily this battle of inches. In the tower context, the landlords are financially motivated. Most of the tower facilities have been consolidated under REITs, and there really is a very clear path to getting rights. The landlords in the right-of-way are local jurisdictions and utility pole owners who have other uses for those facilities besides cellular co-location. And so really sometimes it's not about the money. In fact, at any amount of money, it may be considered a nuisance. And so in the tower context, we're deal-driven, and in the right-of-way, we're engineering standards-driven. And so the majority of the work of the individual siting really has a lot more to do with finding a technical solution that is sensitive to the pole owner's design standards, that is sensitive to the jurisdictional needs of the places that we're located, rather than coming up with the right number of dollars. The other thing about the right-of-way is that it's a dynamic environment. It's busy. There's poles that are already in use by several users. There's mailboxes and street signs, stoplights. There's all kinds of things going on in the right-of-way, and so we're away from that static compound that even though it's multiple tenant, really has a single use. And in the tower context, the capacity of a facility is governed by the king or queen that is the structural engineer. What is the capacity of that facility? In the right-of-way, the king or queen is a traffic engineer or an OSP engineer, either at a municipality or at a pole owner, who has many other considerations besides cellular use as they decide whether or not a facility is different. So as we think about coming into this area in particular, and I see this area as sort of the metro New York, New Jersey, PA metro area, but this is a proxy for many areas that have a deep urban core, but also very dense suburbs. What we find is that the very dense suburbs actually can be quite a challenge. For example, in New Jersey, we face the challenge of home rule. Many communities with different rules and a lot of sovereignty about what they can do. It's important that carriers and third-party hosts be respectful of that home rule and the host community's needs and wants, not just their legal rights. We face busy streets, and sometimes you find that a place like Manhattan, where there's a very prescriptive regime around what happens on poles and what the poles look like and what can be on them, is in some ways simpler than really crowded, ultra-dense suburban area where before we got there's been 100 years of chaos in that right-of-way, and so it can be a little bit more complicated. We often face underground utilities, and in those situations, we can't be the guys that bring wood poles back to places that the wood poles have already gone away, and we need to think about structures that are sensitive and in sync with the very expensive efforts to underground utilities that have already undergone. And then finally, we think about the busy utilities that we're trying to seek co-location with. So I'm generally an advocate for using the maximum use of co-location prior to placing new facilities, and one of the challenges we face is that the existing facilities are busy. They're physically busy, and the people that are dealing with those facilities are busy doing things that are more important than our needs. Finally, there's some scaling concerns here. We heard previous speakers discuss the fact that these nodes are going from hundreds to thousands per market, and a model that deals with monolithic, single site, large site, templated approaches is very difficult to scale in this busy streetscape. And so I think with all of the stakeholders that are involved, we need to sort of reinvent how we think about rolling out these projects in ways that are sensitive to the communities that we're in. Finally, a few pictures here. You'll see some examples. These are two nodes. One is a node that I'm pretty happy with, the brighter color picture there. That happens to be an ODAS node, but it could be anything. I like that the cabinet is longer than it is fat. It's sort of in proportion with the pole. We like vertical rather than sort of horizontal dimensions. The one on the other side, you can see all kinds of cables and spaghetti. I'm of the opinion that you should never see a cable on a small cell. If you're going to install one of these things, spend a few extra bucks and hide all that stuff so it looks nice, and operationally you tend to get a better result there as well. Up here on the I guess your right side, is a small cell in the right-of-way that happens to be down in the communication space, so it's down low. This is a solution in an area where there's a lot of deciduous trees, and to Dominic's earlier point, we're often in the clutter, and so sometimes height isn't the answer. Sometimes being a little lower is nice, and this is an example of putting that node down low. And you can see in the detail picture where the installer is working that the cables can be hidden, and so it's way out on a bracket, but the things don't have to be exposed. Down here, you see a thing that looks like a Bob stroller. I think it might have some common components with a Bob stroller, but that's a ground penetrating radar. And that ground penetrating radar is now part of the site acquisition process as we look to place new poles or underground facilities to reach existing poles. Being part of the dig-safe environment in the busy streetscape is a really important engineering consideration. And then the picture with the bucket truck there is probably one of Dom's CW tests. We might have been using one of our trucks, but in this case, again, testing in the right-of-way, taking a measure twice and cut once approach in the right-of-way is really important. This is a picture down on the shore, and what I want to point out about this picture, and it may be a little difficult to see, is that this is on the beach, but the pole is not right down on the beach. It's situated in such a way that people who are looking out at the beach from the shore or from the parking lot don't have to look through a pole silhouetted against the ocean. And I just want to reemphasize that, as cellular people, if we want to win the hearts and minds of the communities that we're hoping to serve, we need to be sensitive about where we put these facilities. In this case, this is a situation, as Don described, where there need to be some panel antennas and some directionality to it, so it's a little bit of a more visible node. And the kind of things you need to do when you have a more visible node is to make sure that you put it in a place that's sensitive to the fact that people might have to look at it and silhouette it to the lowest extent possible. So with that, I'll turn it over to Leslie, who I think is going to help us understand, once we know where we want to put this thing, how we get to yes.
I'm sorry, what? Oh, okay. Good morning, everyone. Now that Dominic told you how easy it is to do RF testing and figure out what poles you want, and Josh told you how to identify the poles, we're now going to get down to that you can't actually start your work yet because now you've got to face the municipality. And essentially what's happening all over Westchester right now and other municipalities outside New York City is they're gearing up to start looking at these installations. And we thought towers were bad and trying to get towers approved in these communities. Watch out. Now it's ODAS. So my first real point is what gives the municipality the right to govern these installations. And in New York, they have the Transportation Corporation Law, which says that the municipality has the right to give you permission to use their streets. And you also have the federal law, 253, which basically says a municipality has to act in a competitively neutral manner and cannot prohibit or have the effect of prohibiting telecommunications services. But that doesn't mean that you don't have to go get their consent, because in 332 of the Telecom Act, they preserve the local authority's right to govern the right-of-way and to govern telecommunications facilities. So the bottom line is you are stuck. You've got to get local approval. And really what you find out that the ideal RF design and maybe the ideal pole design isn't always the ideal zoning permitting design. The first thing that happens is most municipalities require you to get a right-of-way use agreement. And so you approach the municipality. Some of the municipalities even have a statute that deals with these right-of-way use agreements, which generally governs the terms. Some of them say they can only be 10 years. Some of them, they all basically provide that they can relocate you if they need it for a public purpose. Some of them have very elaborate insurance requirements. It also says you have to go through a local permit process, and it may even get into the design. So in New York City, they've had design requirements. Now we're dealing with other municipalities with very stringent design requirements. You will laugh when you think, I just was with a municipality and we were fighting over 2 inches on either side of the pole. That 2 inches on either side of the pole, in their mind, had a major visual impact. So we'll have to see what a judge says. Just taking a step back, and I think Josh sort of alluded to it, the poles that we're picking now are either electricity typically or telephone poles. Some of them are the municipality's own poles. And what we're finding as we go community to community is that the municipality sees dollar signs. So now you come with a design that your RF team said is the best, and suddenly the municipality is saying, well, can you try to use our traffic light? Can you try to use our light poles? Because they want money. They figure if you're coming, you know, money is coming too. So in addition to dealing with the electricity and the utility company and dealing with their onerous documents often, we also have to deal with the municipality and their wishes to try to use their poles. Typically with these utilities, just stepping back, dealing with the utility per se, they usually require 2 documents. One is a wireless attachment agreement for the equipment that you're putting on the pole, and the other one is a conduit type of agreement dealing with the pole-to-pole connections. And again, these, similar to the right-of-way agreements, deal with compensation, their right to relocate you, their right to terminate you, and often these utilities make you utilize all of their staff to do most of the work, so you have to deal with those costs as well as insurance and design. The design is very tricky because we're now faced one municipality where Con Ed has a specific design, and the municipality doesn't like that design and keeps on asking us to do a different design that we know Con Ed isn't going to approve. And so we're in this whipsaw, again, over inches, which sounds silly, but this is what's happening in the real world. And we're trying to appease the municipality at the same time knowing that we have to deal with Con Ed and their requirements. Really, a lot of the zoning issues stemmed from a few cases, and I'm sure there's going to be more that are coming. And sort of the pivotal cases that have happened over the last few years deal with 2 municipalities in Westchester. I'm going to skip first to the Extenet Pelham case, because that case is kind of an interesting case in the sense that Extenet came to Pelham and said, I have this great idea, I want to use your poles. The municipality was on board, and they granted them a right-of-way use agreement, and then they just told them, you don't have to get any permits, our building inspector will just issue you permits. And at that time, they were only going, believe it or not, for 3 nodes. So it was just 3 little poles. Unfortunately, one of those poles was by Mrs. Kaplan. She did not like that pole. And so she actually read the statutes, she went to court, and she's got a TRO against them to stop, and she basically said, hey, the village can't just give away this agreement, they have to go through an environmental process. And in New York State, they have the New York State Environmental Equality Review Act, and that basically says that various land use actions have to go through an environmental process. Well, the village of Pelham never went through any real process. They just approved it. They thought it was a great idea. Hey, it's just 3 little nodes. Who's going to care? Well, they realized that they did have to go through that process to enter into that right-of-way use agreement. So Mrs. Kaplan was successful in making the village go through that process. They also thought that they didn't have to go get a special permit. So most zoning codes have telecommunications facilities laws. And where did those laws derive from? They derived from the Telecom Act back in 1996 when the carriers were coming with those 150-foot towers and all the municipalities were freaked out that they better get some law on the book to stop this real fast. Unfortunately, those laws are very broad and they do apply for installations on poles, because most of them say installations on any structures. So it turned out that in this case, Extenet had to go get a special permit. Needless to say, the case settled, and I think what happened is they moved the node away from Mrs. Kaplan. But the village did, when the new nodes came, they went through the environmental review process and they went through the special permit process. What's happening in the real world also is that now that you're going with these ODAS nodes, if you get a bunch of Mrs. Kaplan, so imagine an audience and you've got now 30 Mrs. Kaplan screaming, "We don't want the node in front of our house," they're suddenly saying, "We would prefer a tower. We don't like nodes, go build what they call a stealth stick." I love this one. So we all know they don't quite look like a stick. We do have to have our panel antennas, either maybe if it's a flagpole, you could try to argue it's a stick, but they're not as slim as we all would like. So we are now finding, particularly in Westchester, that people who are opposing the nodes are suddenly saying they'd rather have a tower until the tower is in their backyard. The Crown Greenberg case is another case. It's actually a very interesting case where Crown came to Greenberg to build some nodes. At that time, it was for Metro PCS. And they went through a lengthy process, year after year, to try to get approval. And Crown was successful in the lawsuit, but the upshot of the lawsuit was the court upheld the town's wireless law to say that you were required to go through local zoning for each node. And that is buttressed a lot of communities now in looking at their law and determining what exactly is required for these nodes. And really what gets tricky on the whole node issue and the right-of-way issue is that, you know, right-of-ways don't provide the same setbacks that the old towers provided. So in a lot of ordinances, they have setback rules from the street, et cetera. Now we're in a right-of-way. We're in the street. So it is becoming quite a dichotomy of how the legislation is playing out and how we're designing our sites. They're also requiring the good old need analysis. So Dominic and Doug and all you RF engineers, you're going to be busy, very, very busy, because we are spending a lot of time analyzing the need and how we can justify the need, because as mentioned, a lot of these sites are dealing with capacity, not coverage. And they're also dealing with LTE technology. So it is becoming a very unusual landscape and a very interesting one. Just other requirements to think about regarding nodes. I worked with an installation in Central Park, and we don't all think about, you know, Central Park and what they require all the time. And what happened was the RF team designed nodes in Central Park. Everyone thought it was fantastic, looked great, looked just like the signs, it wasn't going to have impact. Not so fast. And we had to deal with the Central Park Conservancy, and we must have spent 2 days analyzing every pole, which pole would be more appropriate for the nodes, and why it was more appropriate. And then people would be running around looking at each angle to determine if this pole was appropriate or it was going to ruin some kind of view shed. So pole placement is very, very critical. And I think, as Josh mentioned, I think meeting with the municipality, meeting with the entities that are responsible early on can save you a lot of time and money as well. The other thing to think about is title. So no one likes to ever think about title, and I don't blame you. It is pretty a boring subject. And what do I mean by title? So the question becomes, is there's a right-of-way. And what happens in a lot of these municipalities is it's not so clear where the right-of-way begins and where the property owners end. And most property owners, if you ever look around, especially in suburbia, their lawn goes out into the right-of-way. They'll even have a sign maybe on their lawn, dead end or a stop sign or what have you, but they think it's their property. And so, and some of these right-of-ways are not the clearest, so you have to get out all the maps and figure out where is the right-of-way and where is the private property. And the reason why that becomes very pivotal is if you're on a private property owner's property, not only could it be very expensive, the private property owner may not be amenable to allowing you to put the node there. So title is actually very important with respect to these installations, and not always so easy to find. You would think it would be easier than you would imagine, but it is not. The other thing to think about is the fiber. Where is the fiber going? Is it overhead? Is it underground? And I'm assuming, you know, most entities are looking at what is in the landscape and following the landscape. The only thing that I have noticed is that most neighbors don't have an objection to the cable box that's been up there for 10 years and maybe the utility meter box that's there, but suddenly when they see the node, it doesn't look the same to them, and now it's a big intrusion. So all of these little factors of, you know, any way you can camouflage the conduits and deal with it is, I think, going to be very helpful in the long run, because often neighbors are looking at every little thing that can be objectionable. I just was dealing with a community, and all of a sudden, a neighbor that's had a node in front of their house for several years says it's a terrible noise. And he's claiming that all the noise stems from the nodes, and why are these nodes noisy? And literally, we've had so many people out to this site to try to find the noise that he's objecting to, that it has become quite interesting. Hopefully we're working towards a resolution. But what that actually has spearheaded is this particular municipality, since this man comes to every single public hearing to complain about the noise now that he hears that no one else can really hear, they're changing their noise ordinance, and they're making it so that the nodes are barely like our engineer says, we're on the cusp. So what that could mean is if you have to add carriers to that shroud and there ends up being a more need for additional fans and things like that, that may end up being a problem in the future. I think at this point we're probably up to our time, so maybe, Doug, you want to lead us in some questions.
Thank you, Leslie. We've got about 10 minutes for questions. Hopefully, some of you have some questions for us. Anybody? Right here.
This is the President Leslie, and also Thank you. Earl, I'm with EJL Wireless. The question is regarding not poles, but sidewalks. What's the jurisdiction or legality and right-of-way on sidewalks in municipalities? So if we look at some of the new small cells that are coming out, you could actually vault them in the ground, and you put a cover on them, and the cover is a 2x2 MIMO antenna, looks like a manhole. Who has the right-of-way on the sidewalk? Or have you looked at this?
The question was, who has the right of way in the sidewalk if you were to find a node that maybe could be mounted in some kind of a ground furniture situation instead of a pole? I think that was the question. Yeah,
Sidewalks are owned by the municipality. Yeah, just like the public right-of-ways, the sidewalks are owned by the municipality. So you would have to go and get a right-of-way use agreement to use those sidewalks as well.
yeah, and I would say, you know, I'll give the typical lawyer answer. It depends. What we're finding is that, and this is to Leslie's earlier point about the importance of a title search in these facilities, is that we're finding with alarming frequency that the ownership of the supposed right-of-way is not necessarily clear. A municipality may feel that something is or isn't in the right-of-way. A private pole owner may feel that something is or isn't in the right-of-way, and they may be surfing on a mistake that was made a long time ago. And what you'll find is that when you compare the municipal map, the utilities map, and the DOT's map, that they all conflict. And so we actually feel like a really good starting point on that is a right-of-way determination, because the sidewalk could be the municipality's property or it could be someone else's. We also find that when we say right-of-way is really a layperson's term. Right-of-way has a specific meaning in different jurisdictions, and sometimes right-of-way, even within a jurisdiction, may have nuances depending on who owns the dirt under the right-of-way. Is it a right to do something on top of private property, sort of the traditional meaning of the right-of-way, or is it actual municipal or county property? And so those nuances are really important. I think the sidewalk is an interesting option, but I would just caution that we really need to be sensitive about ADA clearances, American with Disability Act clearances, to ensure that if we do use the sidewalks, that we do that in a responsible way so as not to obstruct it for the disabled.
Other question? Back right?
Yeah, Mike Galinicos from T-Mobile. I had a question about New York City. Question about the New York City, the limitation with the antenna. Building a lot of DAS nodes across the area, having that 2-inch whip antenna severely limits our ability to, do MIMO and really provide high-level capacity that New York City needs. Is there anything that the industry is doing to get them to change that limitation, to perhaps put some panel antennas or some kind of antenna to allow the deployment of MIMO?
We've worked on a couple of different projects with different types of antennas. We're starting to see more types of antennas coming out. I don't know that there's any specific answers yet, but I agree with you. The problem of not being able to do MIMO is an issue, and it's an issue that the industry needs to resolve, and the antennas are certainly one component of resolving of the solution. I mentioned earlier, and Josh had mentioned as well, about capacity. As you know, the MIMO can effectively double or nearly double capacity, so it's important to have it. One of the issues, though, is these little packages, trying to get more, basically, antennas into these small packages, and that's where we've seen difficulty. So, starting to slowly see some things come out, but I haven't really seen much yet. I think it's an opportunity for the antenna manufacturers and the component manufacturers, but I still think there's a lot on the drawing board.
Yeah, I don't know of any specific effort underway in New York City to overcome that specific dimensional challenge. In other urban areas adjacent to New York City, outside of the 5 boroughs, we've had good success with street furniture, with concealment structures at the top of the structure that can have several beam antennas to increase capacity and support MIMO, but I don't know.
Specific
antenna.
Yeah. Right,
Yeah.
right. In that case, it's usually multiple antennas,
Exactly,
right?
yeah.
I also think a lot of the franchise agreements will be coming up in 2019, so maybe that will be an opportunity for DoIT, who generally is governed that, to look into maybe modifying that as the industry has changed.
Okay, I think we have time for another one. Anybody?
Hi, this is pretty much to Leslie. With poles, utility poles, how much, once you get beyond negotiating with utility, do you have more siting issues with the municipalities?
Yeah, yes. Even if we're using obviously a utility pole, you have to get the municipality's consent because the pole is in the right-of-way. So you are forced to, obviously, that is essentially what the law now has developed into. The municipality ends up having that local review is where you're now coming to them and saying, we need to get approval, permits, and then you have to look at each code. And for instance, in Westchester, we have over 20 municipalities, so we have quite a number of different codes that we have to comply with, and they're not all consistent with each other.
I think we have time for another one, too. Anyone else?
Mike is here. What's a real present-day large-scale deployment of a small cell network, a county, other than New York City with the intersection project? What's a good example?
State of New Jersey is a pretty good example. There are a lot of, I know we've worked with TILSON on a lot of projects where throughout the state, a couple of carriers are really pushing this hard. In some cases, it's ODAS, but in many cases, it's just a variety, it's just a collection of small cells in town. So there'll be one township, we'll have 30 or 40, sometimes 50 nodes in a township. Every single one of them will be a small cell node. There are a ton of them in North Jersey, right across the river from here.
I think that's a really good point. I mean, what you're seeing right now is LTE densification. And so in areas where there's excellent coverage, adding an understory of capacity in places where we're facing specific sector exhaust or anticipated immediate near-term sector exhaust. I think when we think about those kind of numbers that we heard earlier in terms of the multiple orders of magnitude above these numbers, we're talking about the roadmap for 5G as the distances between the handsets and the transmitter that they're talking to gets shorter and shorter. And so the nice thing about putting, let's say, 50 nodes in a community is that the necessary front haul fiber to service those 50 nodes lays a groundwork for the proliferation of multiples of those nodes. But to the financial analyst's earlier comment, the costs associated with the nodes that we're deploying, let's say 50 in a community, are not sustainable at 500 nodes to cover the same community. They have to be orders of magnitude different, and the form factors have to be orders of magnitude smaller to meet the needs of that community. Nobody wants to live in a place where they're literally bumping into small cells, right? So we would assume that today we're setting the sort of ground for not having LTE collapse around us under its load. It's sort of a buying time sort of technology, and then it sets the conditions from a front haul fiber standpoint as that technology, form factor, and the right-of-way laws and rules catch up to bring the costs of these down over time. You know, the market will find a new equilibrium then.
Okay, thanks, Josh. Maybe one more quick question, and then we'll wrap up. Anyone? Okay, well, then we'll wrap up. I want to thank everybody for coming to the session. There definitely, if there's any more questions, feel free to approach any of the panelists after we're done here. I want to thank NEDAS for coordinating this, and you know, again, thanks to you all for giving us 50 minutes of your time.